Welcome. Good grief. I was trying to say, welcome back, turd furgateers. Today's video is on the product and the quotient rule. Ooh, I can feel the excitement in the air. So, what do you do when you've got two functions to multiply times each other, or you're dividing two functions? So, let's just go straight into how we do this. So, if we're going to multiply two functions together, we're going to this is the formula that we're going to use. U prime V versus UV prime. It's very easy to remember. Now there's different notations, but I like this way the best. So say for example, let's just get straight into it. When we look down here in this problem, I've got two functions I've got multiplying times each other. I'm going to call the first function U and the second function V. According to the formula, I need to know the derivative of u and the derivative of v. So I need to know the derivative of each one. So let's just go down here and see if we can't do that. So if u is equal to x squared plus 1, what's the derivative of u? Well, that's easy. That's just 2x. Okay, well, I can handle that. Well, let's take a look at the other one. If v is x cubed plus 3, then once again, the equation asks me to find the derivative of my second function. Again, the u and the v are just arbitrary letters that we're picking here. It's just the type of notation to use. Well, the derivative of x cubed plus 3 would be 3x squared. So now all we have to do is think product rule. So what would the notation look like, or what's our formula? Well, the formula for the product rule is, if you need to look at it again, right there it is, u prime v plus uv prime. And now all I'm going to do is fill in my equation. So according to what I've done, u prime is 2x times v, which is x cubed plus 3, plus u, which is x squared plus 1, times v prime, which is 3x squared, and the calculus is over at this point. We could clean this problem up. I don't want to write that for an answer. So let's do some distributing here, and let's write 2x4 plus 6x. And then what have we got over here? Looks like we've got plus 3x4 plus 3x squared. So let's combine like terms, and I think we're ready to write a final answer. So u prime would be equal to, looks like we've got 5x to the fourth plus 3x squared plus 6x. And there is our derivative. Now, we could have just come up here and foiled this, but this was a whole lot. Well, I don't know. It's up to you. You could say it's easier, it might not be, but we'll definitely work a couple of examples where you would not want to try and foil. We'd have a little bit too much meat going on. But that's all we're doing. So we need to identify the two functions. One is u, one is v. Find our derivative of each function, and then we just apply this equation that we've got up here. So let's come on down. Let's try this next one out. Looks like 6x squared times x8, which I'll be honest, I know this technically looks like it meets the criteria for a product rule, but the reality is this one, there's really no need of doing a product rule because all you have to do on this one is just rewrite it. This would be the same as 6x to the 10. And so our answer would be 60x to the 9. Well, now I know what you're thinking. You're sitting here thinking, well, Turtford, could we do a product rule? Well, yeah, we could, because that we could make that u and that v, and we could do a product rule. So let's go over here. U is 6x squared. This would be a good one to learn on. So what would be the derivative of that? Well, that would be 12x. Well, now let's take a look. Let's see that our second function is x to the 8th. So our derivative of that function would be 8x7. So now we can come back, apply our rule, u prime v plus uv prime, and we can just go back in and do some substituting here. So let's see, this would be 12x times v, which is x to the 8, plus u, which is 6x squared. Ooh, I don't know where I'm getting that little symbol in. Times v prime, which is 8x. Woo, I do not think this was the easiest way to do it, but it should still work. So we've got 12x to the 9. And then over here, it looks like we've got 6 times 8. Is that what we've got here? 48x to the 9, which comes out to 60x to the 9. So y prime, although I think you can very quickly tell, while we could do product rule on this one, it was definitely not the easiest way to do it. Let's go and do a couple others here. Let's take a look at this guy. Again, you see it looks just like a product rule because you can tell here's a function, here's a function. We're multiplying them times each other. I'll make this function u and this function v. Could I FOIL this out? Well, yeah, I could do this. I could FOIL it and turn it into a polynomial, but for the sake of this video, let's do it product rule style. So I'm going to make u x cubed plus 7x minus 1. I'm going to make v equal to 5x plus 2. And now I need to find the derivative of both u and v. Well, let's see. This would be equal to 3x squared plus 7. And then the derivative of the other one is just 5. So now let's write our equation down. And I'm going to say write your equation every single time so that you get it memorized. So u prime is 3x squared plus 7. V is 5x plus 2. Looks like we're still going to have to do a little foiling. U is this big old x cubed plus 7x minus 1. And V prime, well, I think I can fit in that V prime, can't I? V prime is nothing but 5. So let's see what happens when we try and get this thing. I mean, we've got it done. I mean, we could say that's y prime, but that's not simplified very much at all, is it? So let's see here. We would have 15x cubed plus 6x squared plus 35x plus 14. Goodness. Plus, I'm going to have to do some thinking here. 5x cubed plus 35x minus 5. And oh my goodness, let's put all this together now. Well, it looks like we're going to have 20x cubed plus 6x squared. Where else we got? We got 35 and 35x. I think I see that. Plus 70x. Then we've got 14 and minus 5. Looks like we've got a plus 9. And there, happy campers, there is our product rule example on that one. All right, so far, this is actually not so bad at all. All right, well, let's see if we can keep going. Oh, and that appears to be our last little introductory product rule question. I'm trying to see if this is on the first worksheet, if there's anything any harder than that product rule-wise. Oh, the weather outside. Oh, I still see some chain rules. Oh, I do see we probably need to do at least one. Yep, cool. I see one more harder example. All right. Well, this one is actually a quotient rule at this point. And the reason why I know it's a quotient rule, if you take a look at this next one, you can tell it's x squared plus 1, and we're dividing it by x squared minus 1. Actually, I hate to say it. I think what I'm going to actually do is I'm going to skip these two quotient rules, make them a second video, and I'm going to go ahead and do this last product rule. So we're going to make this a video entirely devoted to the product rule over here. Now, look at this guy. Now, again, we could actually go into this one. We could actually square that, and then we could multiply it by x4. We could do it. But let's use this and make an example, uv, of the product rule out of it. And so let's make our function u x4, and then let's make u prime. Let's go ahead and do our derivative of that. That would be 4x cubed. Well, that's easy enough. And then let's make our second function v, 5x squared plus 3 square. Now we're going to have to do a chain rule with this one because we've got a function and a function. So the function of the whole thing would be 2 5x squared plus 3 times the derivative of the inside, which would be 10x. And it looks like we've got 20x 5x squared plus 3. I guess I'll keep on simplifying this down. 5 times 20 would be 100x cubed plus 60x. Goodness, we're running out of paper on this one big time here. All right, what am I saying? This is digital paper. I can just, boom, I can have more paper. Oh, technology. All right, it took us a while to get there, but we finally got our v prime derivative down here. So good. Well, now all we've got to do is apply our equation to this. I'm going to scroll down here to do this. U prime v plus u v prime. So let's apply our product rule to this. So u prime is 4x cubed times v, which is 5x squared plus 3 square, plus u, which is x4 times v prime, which is 100 x cubed plus 60x. My goodness, you are getting to be rather ugly, ain't you? Well, let's start trying to simplify this stuff down a little. We've got 4x cubed, 5x squared plus 3 square, plus over here, what in the world have we got? 100, and this one's not going to simplify very pretty, x7 plus 60, oops, I forgot my 60, 60 x to the 5th. And that is my answer. Now, I know what you're thinking. Can we make this prettier in any way? Well, we can't really do a whole lot to make this any prettier than what it already is. I mean, it's just ugly. Some things are ugly. There's nothing we can do. Plus 60, I can rewrite it, but it's not going to make it any prettier. 5x squared plus 3 square, and all I can say is, ladies and gentlemen, y prime is equal to that. It's not a beautiful looking thing, but I could plug in a value for x and get a answer from it. But anyway, so that is our product rule. So one more time, our product rule. You have two functions being multiplied times each other, and you desire to take their derivative. Hey, no big deal. Don't sweat. All you've got to do, u prime v plus u v prime, and bam. Get your u, get your v, get your derivative of each one, and then just substitute into this product rule formula. And you should be having a very good day at that point. So anyway, cheers, and the next video we'll make will be the quotient rule video. But thank y'all for watching. Bye-bye.